Hello and welcome to the Conner Equation Bonus 1. In today's video we'll be going over through one of the things from the introduction video. We had an instance where we went through the x-axis, right? So our side length, the starting point of our side length was on one side of the x-axis and the ending point was on the other side. In the Conner equation you can have different instances of this happening. You can have it where it's going that way diagonally, you can have it where it's going that way diagonally, and you can have it where it's going that way diagonally, and you can have it this going here. I'm not going to go into all the coordinates. Basically, each situation has a phi where the phi is in a different coordinate, magnitude-wise, on the unit circle. I'm not going to go through all four of them in this video. In this video, I am going to, as a reference, show this scenario where phi is between 270 degrees and 360 degrees. So in the video, I wasn't able to prove that this works with the Conner equation. Well, that is what this bonus video here will address, all right? Of course, because I think that is a fair question to ask. I will show you right now, we're going to call AT, that's area of this whole system, area of the trapezoid, as modeled from the Conner equation. I'm going to call this just AT omega. Right now, H1 is a given, okay? H1 is derived from previous things that happened in the Conner equation, in the math, right? So you're going around the polygon and you're adding, subtracting heights up until you get to H1, okay? And that is how you know what H1 is. Okay? Now that I've rewritten it, okay, you guys can see this a little bit better, right? Imagine this in two sections. We have H1 and then we have H1 plus SL sine phi, okay? H1 refers to, well, the height here, H1. H1 plus the side length of SL times sine phi is going to give us H2. This basically right here, oh no. This is H1 plus H2, okay? And if we imagine we factor in SL cosine phi, which is the total length, we get something that actually looks like this. We get, right, this is H1, right? This value right here is H2, and they both share the same side length times cosine phi, which is the same horizontal value, right? Okay, you see that? So I'm saying, wait a minute, the total area of this is the same thing as the total area of this? That sounds crazy. It's easy to see this as related to this, right? You could factor in the SL cosine phi and everything, all that jazz that I just talked about, okay? But what I'm gonna do is I'm gonna get the area of this and the area of this. I'm going to combine them, and sure enough, with some fancy algebra, we will get this. And first, we have our variables, our definitions. A lowercase t 1 plus a lowercase t 2. Oh boy. I hope you guys can see that. Well, I'm saying it. I'm going to say that equals height 1 times base 1 over 2 plus height 2 times base 2 over 2. Now I'm going to define some things here. Height 2, that just equals H1 plus SL sine phi, okay? Right? So we get H2 from using H1, or a given value, SL times sine phi. That's going to get us this. It's going to be negative, right, like on the unit circle. And when you add that into H1, you get down to where H2 is, okay? Now I'm going to say B1. Now B1, I'm going to label this actually. B1, and this is B2. That actually worked out. Okay, B1 is going to equal, let's see, what can we use to get B1? I've got an idea. If we take our H1, right, which is this height right here, and just that height, if we multiply that by the cotangent of phi, we should get B1. The cotangent of an angle equals in the unit circle, the x value over the y value, which is opposite of tangent. The tangent in the unit circle, the tangent of an angle would equal the y value over the x value, which is like the slope of the hypotenuse. The cotangent is the inverse, right? We flip them, okay? So in the unit circle, if you imagine right here that this h1 value, if we put it in the unit circle, if we imagine that that is our y value, okay, and we multiply that by the cotangent of phi, our angle, really quickly, so we got y times the cotangent of phi. I'm going to erase this later, by the way. What this is going to equal is, really quickly, I'm going to also say that the cotangent of phi equals the x over y. In that case, right here, this is y times x over y. The y's cancel. And that just equals x, which is what we want. We want the B1 value, okay? I have to erase this. Now, really quickly, though, we've got a thing to consider, okay? This is very important. H1 is a positive value in this scenario. But when paired with an angle that is between 270 degrees and 360 degrees, we can clearly see it falls here. It falls in this quadrant. In this quadrant, y is negative, okay? If we input our positive value into something that is supposed to be negative, we are actually going to get the wrong answer. So B1 is going to be negative h1 times the cotangent of phi. That's right. Okay, yeah, let's go to H2. H2, how do we get H2? That's very simple. H2 equals H1 plus SL times the sine of phi. There we go. Okay, we got to move along. B2. B2, what is B2? How do we get B2? Well, how about we use handy dandy cotangent, okay? And yeah, let's do it. Parentheses, H1 plus SL times sine phi, close parentheses, times the cotangent of phi. What what does this mean right here? So where am I getting this from? We can see right here, if we could just imagine that, right, it's like that, but over here, just slide it to the left over here. We can see this is a unit circle right here, okay? H2, which is this value right here, and we've got phi. I'll draw the angle right there. That's our angle phi. It's the same angle, okay? These lines are parallel. All these lines right here are parallel to each other, okay? We can see right here, we are still modeling it after our unit circle here. And in this case, H2 would be a negative value. In this case, H2 does not conflict with the cotangent of phi in the Conner equation based on how it is set up. We do have to negativize, we have to add a negative to H1 to when we're dealing with cotangent, okay? That is not the case with H2, okay? Because it already jives well. Same thing if we're going this way, if we're going this way, whatever direction, all four diagonals, it doesn't matter. Anyways, we have to move on, okay? So yeah, cotangent, okay, yeah, we got, because this is our y value, cotangent is x over y, so y divided by y, that's just 1. We get our x, which is B2. Excellent. Okay. Now, now we're going to get this. We're going to fill in all of this. I'm going to do that right here. So we start with, of course, H1 times h1 times negative h1 times the cotangent of phi. Then right here, we have our h2 and b2, all right? That we're gonna be very simple here. I'm gonna use, what am I gonna use? I'm gonna use brackets, I guess. Oh my God. Yeah, just do it, Billy. h1 plus SL sine phi. Okay. Next brackets, parentheses, h1 plus SL times sine phi, close parentheses, cotangent phi, close brackets, extend the line over 2. All right, first things first, what do I see right now? We're going to combine the h1s, obviously. That's going to be negative h1 squared, but we'll do that next. I want to factor in the cotangent here. Yeah, that sounds good. Let's start there. So this is going to be first now. So I'm swapping them, just so everyone knows, okay? All right, so we got h1. We can use parentheses. Plus SL times the sine of phi. Okay, close parentheses. Next, we're going to have h1 times the cotangent of phi plus SL. I'm not going to write it here for the sake of brevity. What is cotangent of an angle? Cotangent theta times sine theta, cotangent phi times sine phi, whatever. Okay, same angle. What do they equal? Well, cotangent is the same thing as cosine over sine. So in fact, these two will cancel to create SL times cosine phi, just like that. And remember, plus, I didn't forget, negative h1 squared times cotangent phi, close parentheses there, all over 2. Okay. We have right here, okay, let's, we can work with this. I'd say we can work with this, guys, right? I'd say we could totally work with this. I'm thinking, let's FOIL this up, right? First, last, whatever, outer, inner, blah, blah, blah. Okay, so we got a first, that's going to be h1 squared cotangent phi. Excellent. H1 squared times the cotangent of phi. And yeah, you guys are right. Already, foreshadowing? I think so. Okay, and then what else we got? We got h1 SL cosine phi. Yeah, that sounds right. Plus h1 times SL times the cosine of phi. It looks a little sloppy, but we can work with it, right, guys? We can work with it. Hang in there. Okay, SL sine phi times h1 cotangent phi. Okay, all right, it's obviously going to have h1 and SL, but sine times cotangent. Cotangent is cosine over sine. So yeah, it's just going to be cosine, just like how it became cosine here from here. Okay, it's literally the exact same thing, okay? So yeah, we'll do h1 times SL times cosine phi. Yeah, they're the same thing. That is true. Very observant, audience. Very observant. And now the last one is SL sine phi times SL cosine phi. That's going to be SL squared sine phi cosine phi. All right? SL squared sine phi cosine phi. Excellent. Let's keep going. And then plus all over 2. The 2 is so tiny. And then negative h1 squared times the cotangent of phi. Right here, we can cancel. Hell yeah. Heck yeah. We can cancel. Oh, over 2. Yeah, we don't have enough space over here, guys. We're gonna have to drop down a level. Okay, we're almost done. That cancels. Excellent. Yeah, yeah. Okay, what are we gonna do? Okay, I'm thinking we'll factor something out. We'll factor out, how about SL cosine phi? Excellent thinking. I'm a genius. Okay, so in that case, we're going to have H1, so the SL cosine phi, and then one of the SLs in cosine phi. So that's all going to go. So that's just going to be H1 plus H1. I'm going to start, I'm gonna start drawing it. All right, H1 plus, H1, right? There's two of them. Plus SL times sine phi. There we go, okay? These are all, this is going to be in parentheses. We factored something out, that's how it works. And then we factor out the SL cosine phi, okay? SL times cosine phi. And remember, we're going to carry in R2. Oh my God. Do you guys see this? I did it. That's right. Oh, I feel great. I've been vindicated. All right? I've been vindicated. Everyone who's watching who thought I was wrong, prepare to eat your breakfast. That doesn't sound right. You can see that I'm right. Yes, that's right. We took the area of this triangle and we combined it with the area of this triangle, okay? And it gets the same thing as this, which is from the Connor equation, okay? It's not intuitive to see that this is equal to these two triangles, the areas of the sum of these two areas. It's not intuitive. I get that. It's intuitive to see this. It's not intuitive that these two areas, once you sum them up, are, after you sum them up, very important, are equal, okay? But through some trigonometry, some beautiful trigonometry that I've displayed here today, you guys now have no doubts. The only doubts you may have is if the different quadrants, right? Oh, what about this quadrant? What about that quadrant? Blah, 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 blah. If there's enough demand, I will, of course, make a video about it. But in the meantime, I think this mission is a success. Goodbye, guys.